fundamental concept behind all intraoral scanners is pretty much the same. The scanner is capturing data and the software is stitching that data together, looking at landmarks, looking at registration points, and doing its best job to align everything as quickly and as easily and as accurately as it possibly can. So I have this exercise that I like to demonstrate. So this is an old school panoramic photo. We've got 6 different photographs of a landscape, and we've printed them out, cut them out, and laid them out and aligned. I think it's a really good example to help us understand what's happening with an intraoral scanner. So we'll start off with the first image. We take an image, and then the software, we capture another image, and then we try and stitch them together. So we're looking at commonality between these. So we've got blue sky, we've got green field, we've got an old stone wall, and a few houses there in the background as well. So what we do is we can line it up like so, but in order to find out exactly where things should be, we're looking at the smaller details now. So I can see there's a house, and maybe it's a solar panel or a sunroof on it, and I line that up there, and we're looking at the details around the stone wall, and it looks pretty much that we've got it. Okay, that's the first one done. And then we move on to the next one, and again, we're looking at commonality. So key things here are, we can see that there's some bushes here and some bushes here, so we know that we're going to be overlaying those to line things up. And we've got these kind of intricate stone wall patterns going on as well. So we're pretty much there as well. And we continue that process. And again, the clouds are helping us here too. So what we're looking at, of course, and when we compare this to intraoral scanning, we got a situation whereby the scanner is looking at teeth and the software is looking at all those intricate details and using them to align everything as best it can. And with an arch where we've got teeth, makes life very, very easy for the software and for the scanner. The challenges arise then when maybe we don't have teeth, we got edentulous spans, we don't have as much specific detail and information to work with. Or we might have other situations that are challenging in terms of details that are moving. So we've got mobile tissue, maybe we've got some teeth that are loose, and that makes things a bit more challenging as well. But I took these photographs many years ago in a particular sequence at the same time. The cloud pattern is the same. We don't have cars moving to upset our images or anything like that. So we've got a really good picture there, panoramic of 6 individual shots, and we've lined them up. It's probably taken me about a minute to do it. Now, of course, for an intraoral scanner, we're taking thousands of images every minute, or maybe even every second, depending on what scanner you're working with. And the software is constantly stitching those together at a very, very high speed. So hopefully that's going to give you an appreciation for how fast and how powerful the software is and how powerful the computer needs to be in order to be able to do that at that kind of speed. Now what I want to look at, let's look at a stitching error. So again, the software is looking at big picture. It's looking at all the details it has, and it's trying to stitch everything together. We've got lots of detail here, but imagine we only had blue sky and green field, and it was a straight line between the two, and we'd no clouds. It would be therefore very difficult for us to get that alignment correct. So that's extreme. It would be extremely difficult for us to do and to do reliably. But again, bearing in mind, in some dental situations, we're scanning where the detail is very, very vague, and therefore it's very hard for the software to stitch everything together, or the software might just need an extra little bit of time to do that stitching. So we also should always be patient, tune into the scanner, tune into the image being generated. If the image is being generated nice and fast and you're moving in a consistent manner, awesome, keep going. If the software starts slowing down a little bit, it's really giving you some feedback, giving you a message to say, I'm struggling here, go slow with those images. Imagine you were here giving me 1,000 images every minute and I'm trying to align them. It's going to be near on impossible. Well, it is going to be impossible. So let's continue on. So we're just keeping these ones as they are. So now I'm looking at a situation again, and I line this one up, and everything is looking good. Now I'm going to try and simulate something, and that is, so we're picture, stitch, stitch, all going together. Maybe we drift off course. So we've drifted off the arch, we've drifted onto finger, onto lip, onto cheek, onto gum, onto tongue, whatever. We've maybe drifted off, so we're not seeing as much information. So now this is the information we're seeing. And we're now bringing in an additional picture. And we could line the picture up like so. If that's all we saw, we might just line it up like that. Or maybe we do see some of the wall, and that's okay. Well, then we can maybe line things up like so. The stones seem to line up there. The grass verge seems to line up there. But what we're noticing then is as we expose the whole area, everything is wrong here. But maybe the scanner hasn't seen that because we've drifted off course. We've drifted off the path. That's all we see. Then we go back on path as we move around the arch, and the scanner sees, okay, well, here's some more information. Let's add it on here and line things up, and that's great. And you can imagine then, as if we were to continue that, we could end up going with the scanner is going off on a completely different trajectory. And that's, I'm not going to say it's a common thing. In the past, it has been common with some scanning technologies. More scanners now, the scanner is getting more accurate information, the software is more reliable, it's more intelligent, but it's still, the key thing here was it was down to the user, that we drifted off path. We maybe drifted off path, we only presented the scanner with a small amount of information. It did its best job lining up that information, but the result is it started drifting. Then what happens? What could happen is, as well, in a combination of which step happens first, is that we come back to here, we start scanning, we start capturing more information, and we end up then adding on information in a different path, i.e. in the correct path. So we could go in the correct path initially and then end up going offline, or go offline first and then go in the correct path. What happens in that situation is we could end up with two sets of data, maybe overlapping or maybe going off on a different tangent. It's something to watch out for. It's inherent across all intraoral scanners. Some scanners handle it better than others. Some scanners you very, very rarely see it. But it's something that does exist, and ultimately it's down to how we scan. So it's really important when we're scanning that we stay on track and keep a really close eye on what's happening on screen, as well as what's happening in the patient's mouth, so that hopefully we can avoid this. We're giving the software as much information as we can on each scan all of the time, and the software is going to make the best and the most accurate decisions to ensure that we get a good, consistent scan every single time. So I hope that helped you understand the concept of scanning and how the software is working, how the software is looking at all of the details. And of course, as always, if you're having any issues, or you have any questions, or you'd like any assistance, by all means, please do reach out to us at support@esmdigitalsolutions.com. Thank you and goodbye.